Blockchain technology has emerged as one of the most revolutionary innovations of the 21st century, captivating technologists, entrepreneurs, governments, and the public alike. Yet for many people, the concept of blockchain remains shrouded in mystery, often associated only with cryptocurrencies like Bitcoin or Ethereum. However, blockchain is far more than the backbone of digital currencies. It represents a new paradigm for how data can be stored, verified, and exchanged across the globe. This guide aims to demystify blockchain by exploring its origins, core principles, practical applications, and potential future impact in a clear and accessible manner. To understand blockchain, it's helpful to start by considering how information and value have traditionally been recorded and exchanged. For centuries, societies have relied on centralized authorities, banks, governments, notaries, to keep records, validate transactions, and maintain trust among participants. These intermediaries serve as trusted third parties, ensuring that money isn't spent twice, that property rights are properly transferred, and that agreements are enforced. While effective, this system is not without flaws. It can be slow, costly, opaque, and susceptible to errors, fraud, or even corruption. The advent of the internet enabled faster communication and commerce, but did not fundamentally change the need for centralized record-keeping and trust. Blockchain was conceived as a solution to this problem, a way to create trust and manage records in a decentralized, transparent, and secure manner without relying on any single authority. The first practical application of blockchain was Bitcoin, proposed in 2008 by an individual or group under the pseudonym Satoshi Nakamoto. Bitcoin's white paper introduced a peer-to-peer electronic cash system, enabling people to send money directly to one another over the internet without a bank or payment processor. At the heart of this innovation was the blockchain, a distributed digital ledger where every transaction is recorded, verified, and permanently stored across a network of computers. But what exactly is a blockchain? At its simplest, a blockchain is a chain of blocks, each containing a collection of data, most commonly, transactions. These blocks are linked together using cryptographic techniques, forming a continuous, unbreakable sequence. Each block contains a unique code called a hash, which is generated based on the block's contents and the hash of the previous block. This chaining of hashes ensures that if anyone tries to alter information in a past block, the change would break the chain, alerting the network to tampering. In this way, blockchain provides immutability. Once information is written, it cannot be changed without the consensus of the network. The decentralized nature of blockchain is perhaps its most transformative feature. Instead of a single server or authority controlling the ledger, copies of the blockchain are held by thousands of computers, called nodes, around the world. When someone initiates a transaction, it is broadcast to the network and grouped with other transactions into a block. Specialized nodes, known as miners, in proof-of-work systems like Bitcoin, compete to validate the block by solving complex mathematical puzzles. The first miner to solve the puzzle adds the new block to the chain and is rewarded, typically with newly created cryptocurrency. Other consensus mechanisms like proof of stake use different methods to achieve agreement among participants, but the core idea remains. No single party controls the ledger, making it highly resistant to censorship, hacking, or manipulation. Transparency is another hallmark of blockchain. Since the ledger is public and distributed, anyone can view the entire history of transactions. This openness increases accountability and trust, as all participants can independently verify the data. At the same time, blockchain employs advanced cryptography to protect privacy and security. Transactions are recorded using digital signatures and addresses, which are not directly tied to real-world identities, offering a degree of anonymity while still ensuring authenticity. Scalability and speed have been areas of challenge and innovation for blockchain systems. Early blockchains like Bitcoin process a relatively small number of transactions per second compared to traditional financial networks like Visa. This limitation arises from the need for every node to reach consensus and maintain a copy of the entire ledger. Over time, various solutions have been proposed and implemented to improve performance, including larger block sizes, off-chain transactions, such as the Lightning Network, and alternative consensus algorithms. Newer blockchains, such as Solana and Avalanche, aim to process thousands of transactions per second, making them suitable for more demanding applications. Beyond cryptocurrencies, blockchain technology has found applications in a wide array of fields. In supply chain management, blockchain enables greater transparency and traceability, allowing companies and consumers to track the origin and journey of products, from raw materials to finished goods, ensuring ethical sourcing and reducing fraud. In healthcare, blockchains can securely store and share patient records, improving efficiency and privacy while reducing administrative burdens. Governments and organizations are experimenting with blockchain-based voting systems, which could enhance security, reduce fraud, and increase voter confidence in electoral processes. Intellectual property, real estate, identity verification, and even digital art, through non-fungible tokens, or NFTs, are being transformed by blockchain's ability to provide verifiable proof of ownership and authenticity. Smart contracts are another groundbreaking innovation made possible by blockchains, particularly on platforms like Ethereum. A smart contract is a self-executing program that runs on the blockchain, automatically enforcing the terms of an agreement when predefined conditions are met. For example, a smart contract could facilitate the release of payment once a shipment is delivered, without the need for intermediaries. These programmable contracts enable the creation of decentralized applications, dApps, and have given rise to entire ecosystems such as decentralized finance, DeFi, where users can borrow, lend, trade, and earn interest on assets without relying on banks or brokers. The concept of decentralization extends to governance as well. Many blockchain projects are managed by decentralized autonomous organizations, DEOs, in which decisions are made collectively by token holders rather than a central leadership. DAOs use smart contracts to encode rules and automate processes, enabling transparent, democratic management of resources and initiatives. This model has the potential to reshape how organizations are structured and operated, fostering greater participation and accountability. Despite its promise, blockchain technology faces significant hurdles. Regulatory uncertainty is a major challenge, as governments grapple with how to classify and oversee digital assets, cryptocurrencies, and blockchain-based services. Issues of scalability, interoperability between different blockchains, and energy consumption, particularly for proof-of-work systems, are ongoing concerns. High-profile hacks, scams, and volatility in cryptocurrency markets have also fueled skepticism and caution among the public and investors. Nevertheless, innovation continues at a rapid pace. Developers are working on solutions such as sharding, splitting blockchains into smaller pieces, Layer 2 protocols, building faster networks atop existing blockchains, and more energy-efficient consensus mechanisms. Interoperability. Projects aim to connect different blockchains, allowing data and value to flow freely across networks. As the technology matures, we are likely to see more user-friendly interfaces, robust security measures, and practical applications that reach beyond early adopters to mainstream audiences. Education and awareness are crucial for the responsible adoption of blockchain. Understanding the risks, limitations, and best practices can help individuals and organizations make informed decisions about how to engage with this technology. It is important to recognize that while blockchain offers powerful tools for transparency, security, and efficiency, it is not a magic bullet for every problem. Careful consideration of use cases, technical requirements, and social implications is essential for realizing the full benefits of blockchain while mitigating potential downsides. The cultural impact of blockchain is also profound. By enabling new forms of collaboration, value creation, and ownership, blockchain challenges traditional notions of trust, authority, and participation. It empowers individuals to take greater control over their assets, identities, and interactions, reducing dependence on centralized institutions. This shift is evident in the rise of decentralized social networks, creator economies powered by NFTs, and grassroots fundraising through token sales and crowdfunding platforms. Looking ahead, the integration of blockchain with other emerging technologies, such as artificial intelligence, the Internet of Things, IoT, and 5G connectivity, could unlock even greater possibilities. For instance, IoT devices could use blockchains to securely exchange data and coordinate actions without human intervention, while AI-powered smart contracts could automate complex decision-making processes in real time. These synergies have the potential to create more resilient, adaptive, and intelligent systems across industries. In the financial sector, central banks are exploring the issuance of digital currencies, CBDCs, built on blockchain-inspired architectures. These digital currencies could streamline payments, reduce costs, and enhance financial inclusion, while raising important questions about privacy, surveillance, and monetary policy. Meanwhile, the continued growth of stablecoins, cryptocurrencies pegged to traditional assets like the US dollar, offers a bridge between the worlds of digital and fiat money, facilitating faster, cheaper cross-border transactions. Environmental sustainability is a critical area of focus for blockchain's future. The energy consumption of some blockchains, especially those using proof of work, has drawn significant criticism. In response, many projects are transitioning to greener consensus mechanisms like proof of stake, and efforts are underway to develop carbon-neutral blockchains. These initiatives aim to balance the benefits of decentralization with the imperative to protect our planet. As blockchain technology evolves, legal and ethical frameworks will need to adapt. Issues such as data privacy, intellectual property rights, taxation, and consumer protection must be addressed to foster innovation while safeguarding public interests. International cooperation and dialogue will be essential, given the global nature of blockchain networks and the borderless flow of digital assets. For individuals interested in getting involved with blockchain, there are many ways to participate. One can buy, hold, or trade cryptocurrencies using reputable exchanges, contribute to open-source blockchain projects as a developer, or experiment with decentralized applications and smart contracts. Education is widely available through online courses, tutorials, and community forums, empowering people from all backgrounds to learn, collaborate, and innovate. The story of blockchain is still being written. What began as a niche experiment in digital money has blossomed into a global movement with the potential to reshape economies, societies, and the very nature of trust. Like any transformative technology, blockchain comes with risks and uncertainties, but also immense opportunities for those willing to explore, learn, and build. By understanding the fundamentals of blockchain, staying informed about developments, and engaging thoughtfully with its possibilities, anyone can be part of this unfolding journey. In conclusion, blockchain represents a foundational shift in the way we think about data, value, and trust in the digital age. Its core principles, decentralization, transparency, security, and programmability, offer powerful tools for reimagining systems across finance, supply chains, governance, and beyond. While challenges remain, the momentum of innovation and adoption suggests that blockchain will play an increasingly important role in our lives. Whether you are a curious beginner or an aspiring expert, the world of blockchain invites you to discover, participate, and help shape the future.